Part C, 2 mole of sulfur dioxide and 2 moles of oxygen gas are mixed and allowed to react and reach equilibrium at 420 degrees Celsius. At equilibrium, it was found that 90% conversion of the sulfur dioxide had occurred. So part 1, write an expression for the equilibrium constant, Kp for the reaction. Okay, so Kp would be equal to
SO3, 2 in brackets, 2 SO3.
So let me pause you there. It's going to be P SO3.
Okay, PSO3.
So once it's K,
partial pressures.
yes, we're looking at that because it's gases. The system is gases. We're looking. So of course, the state of matter in your components in your equation, it matters. It will determine, well, of course, Kc can either be Kp, Ksp, or so on. All right. In this case, we're dealing with gases, so it's Kp we're looking at. We can write an expression for Kp. We're looking at partial pressure, so it will be PSO3
squared.
Correct. Squared. Yeah. Okay, so like I said, it's the products over the reactant, so it will be PSO3 squared because of the 2 in front of the SO3, then over PSO2, and it'll be squared again because there's a 2 in front of that. And what's the other one?
O2, PO2.
Correct.
Now you're just plugging the values.
Well, the first part of the question is just asking us
Oh, the expression, okay, yes.
Yeah. Part 2, calculate the amount of each gas present in the equilibrium mixture. Now this is for 3 marks. Right? Again, we have to calculate the amount of each gas present in the equilibrium mixture. So at equilibrium, using that information, they just give us that only 90% of 2 moles of SO2 were converted. So from that information, we can calculate the amounts of each of these gases in equilibrium. So we have an equation, right? This is the equation at equilibrium. This is a balanced equation. Remember that even from C.A.P.E chemistry, you can use mole ratios to determine the amounts of each component reacting. They give us that 2 moles of SO2 and 2 moles of oxygen gas were mixed together, but only 90% of the SO2 was converted. So we have to do this in terms of a mole ratio, and we also have to factor in the fact that, consider the fact that 90% alone of the 2 molar, sorry, so have to consider that 90% alone of the SO2 converted. So we use that in the mole ratio. So let's start. So the initial amounts. Right? So at the beginning of this reaction, this is what happened. They mixed 2 mole of SO2 gas and 2 mole of oxygen gas. Right? So initially, they mixed 2 moles of SO2 and 2 moles of oxygen. That's our start. The next piece of information now, they said that at equilibrium, only 90% of SO2 was converted. Therefore, 0.9 multiplied by 2, so that is 90% of that 2 moles, which is equal to 1.8 moles of SO2 were used. Here, they give us that information that at equilibrium, only 90% of this was converted. They give us the initial amounts. So we use that information to determine now that only 1.8 moles of SO2 gas were used. All right, so that's 90% of the 2 moles, 0.9 by 2, 90% of the 2 moles. All right, that gives us 1.8 moles of SO2 were used.
Okay.
Reacted. Right? Now, from the equation, we see that the mole ratio of this equation at equilibrium is 2 mole of SO2 would react with 1 mole of oxygen to give 2 moles of SO3. So that's the mole ratio. So let's write our mole ratio now. Right, so that's the mole ratio from the equation. Now, we have to look at the facts, what we know happened at equilibrium, and that is 1.8 moles of SO2 reacted. Since 1.8 moles of SO2 reacted, and we see from the equation that the mole ratio of how they react is that 2 moles of SO2 would react with 1 mole of oxygen, so that's a 2-to-1 ratio there. Then 1.8 mole of SO2 will react with how much moles of oxygen? 2 moles of SO2 is reacting with half of that amount of oxygen.
Oh yeah, 1.8 divided by 2, yes.
So
And it would be 1.8 for the SO3.
good. It will be 1.8 divided by 2.
Mm-hmm.
It'll be 2 times this, which is the original 1.8. Right? Or the ratio of SO2 to SO3 being 2 to 2, that is the same as 1 to 1. So it would produce 1.8 moles. Yeah?
Yeah.
So the final ratio, it will actually be 1.8 moles of SO2 reacted with 0.9 moles of oxygen to produce 1.8 moles of sulfur trioxide. So at equilibrium, this is what happens. That's the mole ratio there. So if this is what happens, okay, meaning that this is what is reacting, this is the amount reacted, this is the amount reacted, this is the amount produced. The question, let's go back to the question. Calculate the amount of each gas present in the equilibrium. So that will be after all of this has occurred. So at equilibrium, the amount of each gas present so for the SO2, that 2 moles now minus 1.8 moles that would have reacted. Yeah? Because 1.8 moles reacted.
Okay.
So you'll have 0.2 moles of SO2 present at equilibrium. That's what remained. What about
Yes, miss.
oxygen?
Mm-hmm.
What about oxygen? We started with initially, that's where we're looking at. We use the amounts that are actually in the system. We plug it into the ratio to determine how much of each reactant reacts, how much product is
Mm-hmm.
produced. So 2 moles of SO2 and 2 moles of oxygen at the beginning, those two were mixed together. At equilibrium, this is what happened. 90% of the SO2 were converted. So using that
Mm-hmm.
information, we were able to determine now the amount of oxygen reacted and the amount of SO3 produced.
Mm-hmm.
Okay, so we're looking at initial compared to final. Initially, we had 2 moles of oxygen. At equilibrium, we determined that 0.9 reacted.
Oh, so
From the
okay,
ratio,
right.
we determined that 0.9 of the oxygen would have reacted. So at equilibrium itself, there would only be, 1.1 moles of oxygen present.
Okay. Mm-hmm.
Right? And how much moles of SO3? The top ratio is from your chemical equation. This is how they react together in this ratio, 2 to 1 to 2. We use the correct amounts that reacted. 1.8 to 0.9 produces 1.8. So if these were the amounts that reacted, we had the initial amounts. All right? You didn't have an initial amount of SO3, you had the initial amounts of reactants. Because remember, SO3 is a product. So you would not have an initial amount of SO3 because that is the product of the reaction.
Mm-hmm.
They give you initial amount of reactants. So if you have initial amounts of reactants, they would react in this ratio to produce a certain amount, which is told by the ratio as well. All right.
Mm-hmm.
So at the bottom here, this is where we determined 1.8 of SO2 reacts with 0.9 of oxygen to produce 1.8 of SO3. So
Mm-hmm.
at equilibrium, the amount of each gas present, because this is the answer that the question is looking for. All right, the question is asking us the amount of each gas present at equilibrium.
Mm-hmm.
So you're minusing how much reacted from the initial amounts to find out how much is left. So at equilibrium, we have these amounts of reactants, 0.2 moles of SO2 and 1.1 moles of oxygen. But these
Mm-hmm.
amounts would have reacted to produce 1.8 moles of SO3, which is your product. So that's the answer. 1.8 moles of SO3 would be present because that's how much was obtained from the reactant.